And welcome back to MechZone. Today we shall be starting with a new subject, that is engineering mathematics, and the first chapter that we have to study in this subject is differential equations. Okay, so जो सबसे पहला चैप्टर है जो हमें स्टडी करना है इट इज डिफरेंशियल इक्वेशंस. ओके, नाउ आपको जानकर ये बहुत ताज्जुब होगा, यू विल बी वेरी सरप्राइज टू नो that everything which is happening in this universe is actually based on one or the other differential equation. सूरज का ढलना, खाने का डाइजेशन ऑफ फूड, सनराइज और जितनी भी एक्टिविटीज जो आपके अराउंड होती हैं, दे आर ऑलमोस्ट ऑल बेस्ड अपॉन सम और द अदर डिफरेंशियल इक्वेशन. और डिफरेंशियल इक्वेशन इसीलिए सबसे ज्यादा इंपॉर्टेंट चैप्टर है क्योंकि इसमें से काफी हैवी वेटेज के क्वेश्चंस आते हैं और इसमें से एक नए क्वेश्चन तो गारंटीड ही होता है हमारे एग्जामिनेशंस में. सो आज हम अपना शुरू करेंगे डिफरेंशियल इक्वेशन. एंड डिफरेंशियल इक्वेशन में हम अपना सबसे पहले डिस्कस करेंगे व्हाट इज एन ऑर्डिनरी डिफरेंशियल इक्वेशन. ठीक है, तो जनरली जो हमारी डिफरेंशियल इक्वेशंस होती हैं दे आर रिटन इन द फॉर्म, फॉर एग्जांपल dy बाई dx प्लस k इज इक्वल टू t. ओके, तो जो ऊपर न्यूमरेटर में टर्म रहता है y, दिस इज द डिपेंडेंट वेरिएबल एंड द डिनोमिनेटर वाला होता है हमारा इंडिपेंडेंट वेरिएबल. ठीक है, तो यहां पर हमारा y जो है वो डिपेंडेंट है, x जो है हमारा इंडिपेंडेंट है. जबकि अगर मैं लिख दूं dx अपॉन dt प्लस ky इज इक्वल्स टू m, तो यहां पर x हमारा डिपेंडेंट वेरिएबल हो जाएगा, t हमारा इंडिपेंडेंट वेरिएबल हो जाएगा. ठीक है, तो ऑर्डिनरी डिफरेंशियल इक्वेशंस आर दोज इन विच द डिफरेंशियल कोएफिशिएंट्स ऑल विथ रिस्पेक्ट टू अ सिंगल इंडिपेंडेंट वेरिएबल. मतलब थ्रू आउट द इक्वेशन हमारा सिर्फ एक ही इंडिपेंडेंट अगर वेरिएबल होगा देन दैट इक्वेशन इज कॉल्ड एज द ऑर्डिनरी डिफरेंशियल इक्वेशन. फॉर एग्जांपल x स्क्वायर dx प्लस y स्क्वायर dy इज इक्वल टू 0. We will divide the entire equation by dx or with dy, and अगर हम dx से डिवाइड करेंगे we will obtain x square plus y square dy upon dx, this is equals to 0. तो यहां पर आप देख रहे हैं कि थ्रू आउट द इक्वेशन इंडिपेंडेंट वेरिएबल आपका y है, इंडिपेंडेंट वेरिएबल x है. तो ये होगी हमारी ऑर्डिनरी डिफरेंशियल इक्वेशन. एक और एग्जांपल जैसे d स्क्वायर x अपॉन dt स्क्वायर प्लस ए स्क्वायर एक्स इज इक्वल टू 0. तो यहाँ पे हमारा x डिपेंडेंट वेरिएबल है, t हमारा इंडिपेंडेंट वेरिएबल है, थ्रू आउट सेम चीज चल रही है. मतलब जो हमारा डिफरेंशियल कोफिशिएंट है, ठीक है, वो तो हमारा सेम ही रहा. ठीक है, वेरेज जो हमारा इंडिपेंडेंट वेरिएबल है वो हमारा सिंगल ही इंडिपेंडेंट वेरिएबल होगा. अब जैसे मान लीजिए यहाँ पर हम लिखें y इज इक्वल टू एक्स dy बाई dx प्लस एक्स स्क्वायर होल अपॉन dy बाय dx. तो ये भी हमारी ऑर्डिनरी डिफरेंशियल इक्वेशन है बिकॉज थ्रू आउट हमारा जो डिफरेंशियल कोफिशिएंट है वो तो y ही है, सच दैट y इज अ डिपेंडेंट वेरिएबल एंड x इज इंडिपेंडेंट वेरिएबल. सो दीज टाइप्स ऑफ इक्वेशंस आर कॉल्ड एज ऑर्डिनरी डिफरेंशियल इक्वेशंस. नाउ ऑन द कॉन्ट्ररी वी हैव पार्शियल डिफरेंशियल इक्वेशन. तो पार्शियल डिफरेंशियल इक्वेशन क्या होती है? इट इज अ टाइप ऑफ इक्वेशन इन विच देयर आर टू और मोर इंडिपेंडेंट वेरिएबल्स. वी हैव टू और मोर इंडिपेंडेंट वेरिएबल्स, मतलब दो या दो से ज्यादा इंडिपेंडेंट वेरिएबल्स की प्रेजेंस होगी एंड पार्शियल डिफरेंशियल कोफिशिएंट्स विथ रिस्पेक्ट टू एनी ऑफ देम. और जो हमारा पार्शियल डिफरेंशियल कोफिशिएंट होगा इट कैन बी आइदर based upon these independent variables. For example, if we write the equation x square dz upon dx plus y dz upon dy is equals to 3z. Now we see that here the independent variables are x and y and the dependent variable is z. And this dependent variable or the differential coefficient is being written in terms of these two independent variables, and hence this becomes a partial differential equation. And for example, del square y upon del t square, this is equals to a square del square y upon del x square. So in this equation also, y is the dependent variable, t is independent variable, and similarly x is also independent variable. So we are having more than 2 or more independent variables, and the differential coefficient y is written both in terms of t as well as in x. So this becomes the partial differential equation. Okay, now next we come to what is the order and degree of a differential equation. Order and degree of differential equation. So the highest order, जो highest आपका derivative होगा, highest derivative is actually the order, and the power of this derivative is the degree, and the power of highest derivative is the degree of differential equation. ठीक है. For example, we have a differential equation like 1 plus dy by dx whole square whole to the power of minus 5 by 3. This is equals to a d square y by dx square. ठीक है. अब अगर आप यहां देखें, so this is dy by dx and this is d square y by dx square. तो हाईएस्ट डेरिवेटिव तो हमारा सेकेंड पावर का, मतलब सेकेंड ऑर्डर का हो गया. सो यहां पर ऑर्डर क्या हो गया, ऑर्डर इज इक्वल्स टू 2, क्योंकि हमारा ये सेकेंड ऑर्डर डेरिवेटिव है, ये हमारा फर्स्ट ऑर्डर डेरिवेटिव है, और यही जो हमारा हाईएस्ट ऑर्डर डेरिवेटिव है, इसकी डिग्री कितनी है, द डिग्री इज 1 एंड हेंस द डिग्री वुड बी 1 नहीं होगी यहां पे. ठीक है, बस यही इसलिए एग्जांपल लिया कि ऑर्डर तो यहां पर 2 है लेकिन डिग्री यहां पर 1 नहीं होगी. वो इसलिए नहीं होगी क्योंकि बिकॉज ऑन द लेफ्ट हैंड साइड हमारी पावर है -5/3. तो हमें इसको सही करना पड़ेगा. तो व्हाट वी विल डू इज वी विल टेक क्यूब ऑन बोथ द साइड. सो 1 प्लस dy by dx whole square to the power of -5. This is equals to a d square y by dx square to the power 3. ठीक है, तो जब पावर 3 किया तो हमने यहां पर देखा कि इसकी डिग्री कितनी आ गई, 3. Hence the degree here is not 1, the degree is 3. ठीक है, डिग्री क्या हो गई हमारी 3. तो ये तो था हमारा ऑर्डर एंड डिग्री ऑफ द डिफरेंशियल इक्वेशन. अब एक ऐसे ही अगर हम एग्जांपल करें, d cube y upon dx cube plus 4 under root dy by dx whole cube plus 5 square is equals to 0. Here we have to find out the degree and the order of the equation. देखिए ऑर्डर ऑफ द इक्वेशन तो आप देखिए यहाँ थर्ड ऑर्डर डेरिवेटिव है. ठीक है, और ये फर्स्ट ऑर्डर डेरिवेटिव है, तो डेफिनेटली हमारा ऑर्डर तो हो गया 3. ठीक है, पर डिग्री निकालने के लिए आप सिंपली इसकी पावर 1 नहीं लिख सकते. ठीक है, इसके लिए हमें क्या करना पड़ेगा, वी विल टेक दिस टर्म ऑन द लेफ्ट हैंड साइड एंड वी विल स्क्वायर दीज टर्म्स. तो लेट मी राइट इट डाउन अगेन. सो वी हैव d cube y upon dx cube would be equals to -4 times under root dy by dx whole cube plus y square. What we will do is we will square the terms on both the sides. So this would be square and this would also be square, and hence the final expression would be d cube y upon dx cube whole square. This is equals to 16 times dy by dx whole cube plus y square. So the final power of this higher derivative is coming out to be 2, and hence the degree is 2, and the order we have already calculated is as 3. Okay, so this is how we are going to find out the order and derivative, order and degree of the differential equation. Now there is a Blasius equation, and the Blasius equation is d cube f upon d eta cube plus f upon 2 d square f upon d eta square. This is equals to 0. ठीक है, so first we have to find whether it is a ordinary differential equation or not. it is an ordinary differential equation. Why? Because we are having only one independent variable and there is only one dependent variable and only one independent variable. Eta is the independent variable, जो डिनोमिनेटर में होता है वो इंडिपेंडेंट हो गया, एंड f इज द डिपेंडेंट वेरिएबल. तो ऑर्डिनरी तो हो गया, ठीक है. बट अब हमें फाइंड करना है कि इसका ऑर्डर क्या है और इसकी डिग्री क्या है. द ऑर्डर वुड बी डेफिनेटली 3 बिकॉज द हाइएस्ट डेरिवेटिव इज 3. सो ऑर्डर इज 3, ठीक है. बट सिंस द डिफरेंशियल कोएफिशिएंट इज मल्टीप्लाइड विद द one of the terms, hence this equation will be called as non-linear. This equation would be called as non-linear third order ordinary differential equation. ठीक है. अगर मान लीजिए यहाँ f/2 नहीं होता, if f/2 would have been absent, then simply this equation would have become third order ordinary differential equation and it was linear also. But non-linear का condition क्या है? In case of the non-linear equations, one of the dependent variables is multiplied in the coefficient term. Okay, so this was about the Blasius equation, and this question has also been asked many number of times. Okay, now we will discuss about the different types of first degree differential equations. So first is equations with variables separable. We have variables separable, where the variables can be separated. Okay, for example, we have dy by dx is equals to e to the power of x plus y plus x square y. Now we can see that this can be written as e to the power x dot e to the power y plus x square, this is e to the power y. Okay, so we can see that e to the power of y is common. We have e to the power x plus x square. Okay, this is equals to dy by dx. Now what we will do is we will take all the terms with y coefficient on one side and that of x on one side. So here we will obtain dy upon e to the power of y is equals to e to the power x plus x square dx. Okay, so what we will do is we will simply integrate both the sides. Okay, and this can be written as e to the power of minus y dy integral e to the power x plus x square dx. Okay, now we will solve this equation, and we already know that upon solving we will get minus e to the power of minus y is equals to e to the power x plus x cube upon 3 plus some constant. So this would be the final solution. So this was the case when we were having the variables which can be separated from the equation. Now the next type of equation is homogeneous equation. Okay, so in the first lecture we will be studying only about the theory of the entire chapter, and in the next lecture we shall be solving the problems. Okay, so next type of equation is homogeneous equation. Okay, homogeneous equation. Homogeneous simply means each term is having the same degree. Okay, so homogeneous simply means each term is having the same degree. Okay, for example, y square minus x square dx minus 2xy dy is equals to 0. Now if we look at each term, this is having power 2, this is also having power 2. Now x was having power 1, y was also having power 1, so consecutively this term is having power 2. So each term is having power 2 and hence it is a homogeneous equation. Okay, and the method to solve the homogeneous equation is that we will let v is equals to yx, then on differentiating both the sides with respect to x, dy by dx is equals to v plus x into dv upon dx. यहाँ पर हम लोग चेन रूल लगाएंगे and by applying the chain rule we will obtain this is equals to this. Okay, so we simply have to put this, and then we will have to apply the separation of variables. Separation of variables will be now applied here. Okay, so I will solve this equation. What we will do is, here we can see that dy by dx is simply equals to y square minus x square upon 2xy. Now put y is equals to v into x. So this becomes v square x square minus x square upon 2vx square. And from here we can take x square as common. So we will obtain as v square minus 1 upon 2v. This is equals to dy by dx. Now dy by dx is equals to v plus x dv upon dx. This is equals to v square minus 1 upon 2v. Okay, so what we will do is, we will take the terms of x on one side and the terms of v on one side. So x dv upon dx, this would be equals to v square minus 1 upon 2v minus v. Okay, so after solving this, we will obtain v square minus 1 minus 2v, v square minus 1 minus 2v upon 2v. This is v square, this would be 2v square. So v square minus 2v square is minus v square minus 1 upon 2v. Okay, so x into dv upon dx, this is equals to minus v square plus 1 upon 2v. So what we will do is, we will take the terms of v on one side and terms of x on one side. So 2v upon v square plus 1 dv, this would be equals to dx upon x. Okay, so we can keep the minus sign here. So we will simply integrate both the sides, and this would be the indefinite integration, and we will solve it further. This method is only applicable when the equation is a type of a homogeneous equation. Okay, ये अगर हमारी homogeneous equation होगी तभी हम ऐसे इसको solve कर पाएंगे. Okay, now the next and the most important type of equation is Leibniz equation. Leibniz equation. Okay, and the Leibniz equation is the standard form of dy upon dx plus py is equals to q, where p and q are actually the arbitrary functions of x. ये क्या होते हैं हमारे functions of x हो जाते हैं. Now to solve these types of equation, we will multiply both the sides by e to the power integral p dx. This is actually called as the integrating factor. This is called as the integrating factor. So we will multiply both the sides by the integrating factor, and integrating both the sides we will obtain the solution as y into integrating factor e to the power of p dx. This is equals to integral q into e to the power integral p dx dx plus c. So what we have done is, we have simply multiplied with the integrating factor on both the sides. Okay, now I will solve one question regarding to this. Now we have been given a question, dy upon dx plus y upon x is equals to x. So if we compare it with the equation dy by dx plus py is equals to q, so from here we can say that p is equals to 1 upon x and q is equals to x. Now integrating factor is e to the power integral p dx. This would be e to the power integral 1 upon x dx, and this would simply be e to the power integral. So this we will obtain e to the power ln x, and this is simply x. Okay, so integrating factor is x. So y into the integrating factor is equals to integral q into integrating factor dx plus c. This is the solution. So y into x, integrating factor is x, is equals to integral q is x multiplied by integrating factor, that is x dx plus c. So this would be xy is equals to x square का इंटीग्रेशन हो जाता है x cube upon 3 plus c. Okay, so this is the solution, or it can also be written as y is equals to x square upon 3 plus c upon x. We have simply divided by x. Okay, so this was the type of Leibniz equation. Okay, and next we will start with the exact differential equation. This is a very important type of equation because this we have already studied in thermodynamics. Okay, now we will start with exact differential. Okay, an exact differential equation is simply in the form of m dx plus n dy is equals to 0. If this is the equation, then this equation becomes the exact differential equation when del m by del y is equals to del n by del x. Okay, so this is the actual condition for an equation to become exact differential equation. Okay, so this would be the condition for exact differential equation, and the solution of these types of equation is generally given by integral m dx plus integral terms of n not having x, मतलब जिनके टर्म्स वो वाले टर्म्स जहां पर x मल्टीप्लाइड नहीं हो, जिनका कोफिशिएंट x नहीं हो, dy is equals to constant. So this is actually the solution of exact differential equations. Okay, now for example we have been given x cube plus 3 xy square dx plus 3x square y plus y cube dy, this is equals to 0. So this might look like to be m dx plus n dy is equals to 0, such that m is equals to x cube plus 3xy square and n is equals to 3x square y plus y cube. Okay, so first we will check whether this is exact differential equation or not. Del m by del y should be equals to del n by del x. So first we will find out del m by del y. So this would be 6xy and del n by del x would be 6xy. So since these two are equal, hence this equation is an exact differential equation. Now the solution of this equation would be integral m dx. M simply means x cube plus 3xy square dx plus integral terms of n not containing x. So this term is containing x and this is not, so it would be y cube dy is equals to constant. Now we will simply integrate this equation and we will obtain the answer. Okay, so this is how we are going to find out the solution of an exact differential equation, but first we have to make it a confirmation that whether the given equation is exact or not. But however, one equation can also be made to exact equation by a method that I am going to discuss now, and this is very important. So equations reducible to exact type. Okay, exact differential equation की तरह हम इन्हें कर सकते हैं. For example, we have been given m dx plus n dy is equals to 0. Now what we will try to find out is del m by del y minus del n by del x, okay, whole upon n if this is a function of x only. Okay, if this term is coming out to be a function of x only, then what we will do is then integrating factor would be equals to e to the power integral f of x dx. यही वाले को e की पावर f ऑफ x dx में चढ़ाकर हम इंटीग्रेटिंग फैक्टर बना लेंगे, ठीक है। और इंटीग्रेटिंग फैक्टर बनाने के बाद वी विल सिंपली मल्टीप्लाई बाय द इंटीग्रेटिंग फैक्टर ऑन बोथ द साइड्स एंड वी विल सॉल्व, ओके। एंड सॉल्व कैसे करेंगे, वही तरीका, इंटीग्रल ऑफ m dx प्लस इंटीग्रल टर्म्स ऑफ n नॉट हैविंग x dy is equals to constant. So ये तो फर्स्ट मेथड था. The second method was we will find out del n by del x minus del m by del y. देखिए जो यहां लास्ट में आएगा उसी का नीचे लिख लिया, तो यहां पर भी क्या लिखेंगे, अपॉन m be a function of y only. अगर ऐसा हुआ, this becomes a function of y only, then the integrating factor would be e to the power integral f of y d phi. And we will multiply with this integrating factor on both the sides and we will obtain the solution as same method. Okay, so this was a little bit about equations which can be reducible to the exact type. Now we will start with the most important part of this chapter, that is linear differential equation of nth order. Okay, they are of any order, say n. If it is a linear differential equation, it simply means that the dependent variable is not multiplied to any of the differential coefficients. Okay, so here we have to keep in mind that since it is a linear differential equation, then the dependent variable would not be multiplied with any of the differential coefficients, and it is the nth order, so means order can be anything. And in order to solve these equations completely, the complete solution simply consists of two parts, that is complementary function plus the particular integral. Okay, so the complete solution of the linear differential equation of the nth order mainly comprises of two parts, that is complementary function plus the particular integral. So this is the total solution. Okay, this is the total solution. So we will discuss how we can find out this complementary function and how this particular integral can be found out. So for example, first we will discuss about how to find out the complementary function. Actually, what is the main point here is we will find out the equation or the auxiliary equation. We will find out the auxiliary equation, and from that equation we will find out the roots. Okay, and depending upon the nature of those roots, we are going to determine the complementary function. Okay, so the equation would be in the form of, say, d square plus 2d plus 1 is equals to 0. Now say we have roots, first root is m1, second root is m2. Okay, now depending upon the nature of these roots, the complementary function can be derived as follows. Say these two roots are real and different. मान लीजिए ये roots हैं, real हैं and different हैं. Then if they are real and different, the complementary function is simply written as y is equals to c1 e to the power m1x plus c2 e to the power m2x, where c1 and c2 are actually arbitrary constants. Okay, they are constants. So m1 and m2 are different also. Okay, now this was the case when they were real and different. Now we will discuss about the second case where there would be real but they would be same. For example, if m1 is equals to m2 and let this be m. Okay, so how we are going to write down the complementary function for this? So when roots, that is m1 is equals to m2 is equals to m, the roots are real and equal, then complementary function y is equals to c1 plus c2x e to the power mx. Okay, so y is equals to c1 plus c2x into e to the power mx. Okay, so this is how we are going to find out the complementary function when the roots are real and equal. This was the case number 2. Now the third case is if the roots were imaginary. If the roots were imaginary, and we know that these imaginary roots always exist in conjugate pairs. So let the first one is alpha plus iota beta, and the next is alpha minus iota beta. These are actually the pair of roots, and these are conjugate pairs. These are the conjugate pair of roots. That is, if one is alpha plus iota beta, other would be alpha minus iota beta, such that this is root number 1, that is m1, and this is root number 2, that is m2. It means m1 is equals to alpha plus iota beta and m2 is equals to alpha minus iota beta. Okay, so how we are going to write down the complementary function? We will write it as y is equals to e to the power of alpha x c1 cos beta x plus c2 sin beta x. Okay, so this is how we are going to write down the complementary function in case of imaginary roots, such that these imaginary roots are alpha plus iota beta and alpha minus iota beta. Okay, now the fourth and the most toughest case amongst all is if the roots are imaginary. And trust me, GATE is never going to ask any question based upon this, because it generally becomes a little bit tougher. So imaginary roots which are equal. For example, if both the imaginary roots that we are obtaining are equal, okay, and if this is a case, okay, if this is a case, then y is equals to e to the power of alpha x c1 plus c2x cos beta x plus c3 plus c4x sin beta x. Okay, so this is how we are going to find out the complementary function when the roots are roots are imaginary and they are equal. Now I will solve one question and I will tell you how we will find out these complementary function. For example, the equation d square y upon dx square plus 2 dy by dx plus 17y, this has been given as 0. Now this d square y upon dx square can be written as capital D square plus 2, this is written as capital D plus 17, this whole y is equals to 0. Okay, now what we will do is we will find out the roots first. Okay, now since we can see that this is equation, it is not having any real roots, so we will apply the Sridhar-Acharya method, that is minus b plus minus under root b square minus 4ac upon 2a, where the equation is in the form of ax square plus bx plus c is equals to 0. So from here we can see that a is equals to 1 because the coefficient of square power wala is 1. The coefficient of x, that is d, is 2 and c has been given as 17. So the two roots which can be obtained from here are m1 is equals to minus 1 plus 4i and m2 would be minus 1 minus 4i. So this is actually in the form of alpha plus iota beta, and this is alpha minus iota beta, such that alpha is equals to minus 1 and beta is equals to 4. Okay, so alpha is equals to minus 1, beta is equals to 4. So we will write y is equals to e to the power of alpha x. Alpha is minus 1 into x. C1 cos beta x, beta is 4, plus C2 sin beta x. So this simply becomes the complementary function for the above equation. Okay, now we will discuss the second part, that is how to find out the particular integral for the equation. So there are certain rules regarding the finding of particular integral, and I will discuss those rules. So now we will discuss about rules for finding out the particular integral. Okay, now how to find out the particular integral? The first case is when we are having say we have been given d square y by dx square plus a dy by dx plus k is equals to capital X. Okay, such that this capital X is some function of x. So if this term is not zero, then we will find out the particular integral. और प्लीज माइंड, क्योंकि अगर आपका ये टर्म जीरो है तो पर्टिकुलर इंटीग्रल फाइंड करने की कोई जरूरत ही नहीं है, पर अगर ये जीरो नहीं है तो आपको पर्टिकुलर इंटीग्रल भी अपना फाइंड आउट करना पड़ेगा. सो द फर्स्ट केस इज व्हेन x is actually a type of a function such that it is e to the power ax. अगर आपका जो x है, it is a function of e to the power something x. So what we will do is we will simply find out 1 upon fd of e to the power ax. This is equals to 1 upon f of a e to the power ax. ठीक है, provided f of a is not equals to 0. अब ये 1 upon ft क्या है? तो ये 1 upon जो d होता है ऑफ x है, ये होता है इंटीग्रल x dx. ठीक है, और अगर हम लिखते हैं dx तो dx सिंपली मींस d बाय dx. तो 1 अपॉन d का मतलब होता है इंटीग्रल जो कि है, और dx का मतलब होता है सिंपली डिफरेंशियल. ओके, नाउ फॉर एग्जांपल वी हैव बीन गिवन दैट इन अ क्वेश्चन d स्क्वायर प्लस 4y इज इक्वल्स टू say we have been given 6 e to the power 3x. Okay, so this capital X is actually a function e to the power 3x. So what we will write is 1 upon f of d square plus 4 is equals to 1 upon f a. If we compare it with e to the power ax, then a is actually 3. So f of a means f of 3 e to the power 3x, and 6 तो यहां पे रहेगा ही रहेगा. ठीक है, so 6 upon f of 3 simply means we have to keep the value as 3. So we will obtain 3 square plus 4 e to the power 3x. So we will obtain 6 into e to the power 3x upon 9 and 4 13. So this actually is the particular integral for the given differential equation. Okay, यहां मतलब फंक्शन लिखा, यही वाला फॉर्मूला फॉलो करेंगे. e to the power ax, a की वैल्यू यहां पे 3 है, so we will put instead of d we will put a, and a is 3. So 3 square plus 4, and this would be 9 plus 4 13. So 6 e to the power 3x plus 13. Okay, and for example if this f of a by chance becomes 0, अगर ऐसा होता है, then we will have 1 upon fd of e to the power ax. In that case would become x into e to the power ax upon f dash a. F dash a simply means we are going to differentiate this equation once, and then we are going to put the value of a in that equation. ठीक है, so this is applied when f of a is equals to 0. ठीक है, so this was how we are going to calculate the particular integral when the function this is somewhere e to the power x type. Now second case is when x is sine ax plus b or cos ax plus b. Okay, so 1 upon fd square of sine ax plus b would be equals to 1 upon f of minus a square into sine of ax plus b, provided f of minus a square is not equals to 0. ठीक है, अब यहां पर हमने f of d square ले लिया है, जहां की पहले हमारा था सिर्फ f of d. Okay, now I will solve one question regarding to how we are going to find out the particular integral if the function is sine के form में होगा तो. Okay, so for example we have been given d square plus 4 into y is equals to sine 3x. Now this is actually capital X and this can be written as sine 3x plus 0. So if we compare it with sine ax plus b, here a is 3, b is 0. Okay, now 1 upon fd square of sine ax plus b, this is equals to 1 upon f of minus a square sine of ax plus b. Okay, now we will keep the value of a in the equation this, that is 1 upon minus of a square simply means 3 square plus 4 minus of a square, माइनस a का होल स्क्वायर नहीं है, माइनस ऑफ a स्क्वायर. ठीक है, यहां पर बस बहुत ज्यादा ध्यान देना है, दैट इज माइनस ऑफ a स्क्वायर, ना कि माइनस a का होल स्क्वायर. ये नहीं है, माइनस a का स्क्वायर है, तो माइनस a स्क्वायर साइन ax प्लस b. So this is 1 upon minus 9 plus 4 sine 3x. So this becomes minus 1 upon 5 sine 3x. So this simply becomes the particular integral of this equation. Okay. Now for example, the third case we will discuss that if the capital X function is some x to the power m. Say if capital X is some x to the power m, मान लीजिए x स्क्वायर ही हो जाता या कुछ भी हो सकता है. So what we will do is 1 upon fd of x to the power m, this is equals to f, ये ऊपर ले आएंगे तो this can be written as fd to the power minus 1 x to the power of m. So here we will apply the binomial expansion. Here we will apply the binomial expansion. Okay, and the binomial expansion will be applied here such that 1 plus d की power minus 1 would be 1 minus d plus d square plus so on. इसके आगे आपको जरूरत भी नहीं पड़ेगी क्योंकि स्क्वायर तक ही पूछा गया है और पूछा जाता ही है. ठीक है, so for example we have an equation d square y upon dx square plus dy by dx is equals to x square plus 2x plus 4. Okay, so यहाँ आ जाएगा d square plus dy, this is equals to x square plus 2x plus 4. So we will take d common. So here we will obtain 1 plus dy x square plus 2x plus 4. So we will write 1 upon fd. fd simply means d into d plus 1 into x square plus 2x plus 4. This simply would be 1 upon d, okay, into d plus 1 to the power of minus 1 x square plus 2x plus 4, and this would be 1 upon d. So 1 plus d to the power of minus 1 is 1 minus d plus d square. So 1 minus d plus d square, सिर्फ स्क्वायर तक ही लेंगे क्योंकि यहां भी स्क्वायर ही है. So x square plus 2x plus 4. So we will multiply x square by 1, x square by d. So dx square simply means 2x because d का मतलब होता है डायरेक्ट डिफरेंशियल. एंड d of 4, d4 simply means 0 because 4 is a constant. So after solving this, we will obtain the value as 1 upon d x square plus 2x plus 4 minus 2x plus 2 plus 2. Okay, so 1 upon d x square, 2x minus 2x will be cancelled out, plus 4 minus 2 plus 2. So 4 plus 2 is 6, 6 minus 2 is 4. Okay, so now 1 upon d simply means integral of x square plus 4 dx, and this would be x cube upon 3 plus 4x. Okay, so finally this becomes the particular integral because 1 upon d f of x simply meant integral f of x dx, and d into f of x simply means d by dx of f of x. So by using these simple rules, we are going to find out the particular integral. Now say the fourth condition is if x is equals to e to the power ax into v, where v is also a function of x. Say this is equals to e to the power 3x into x. Okay, so 1 upon fd of e to the power ax dot v, this is simply equals to e to the power ax into 1 upon f of d plus a into v. Okay, for example, we have been given d square minus 4d plus 4y, this is x cube e to the power 2x. So e to the power 2x simply means the value of a here is 2. So 1 upon f of d square minus 4d plus 4 x cube e to the power 2x would be simply e to the power 2x 1 upon f of d plus a. F of d plus a means simply d plus 2. Instead of d we will write d plus 2 whole square minus 4d plus 2 plus 4 into x cube. Okay, so on solving this we will obtain, इसको हम सॉल्व करेंगे तो हमें मिलेगा e to the power 2x into 1 upon d square x cube. ये जब सॉल्व करेंगे तो d स्क्वायर आ जाएगा. d स्क्वायर सिंपली मींस वी हैव टू इंटीग्रेट दिस x क्यूब ट्वाइस. तो जब इसे ट्वाइस इंटीग्रेट करेंगे तो वी विल ऑब्टेन e to the power 2x dot x to the power of 5 upon 20. Okay, so this would be the particular integral. Okay, तो ये हो जाएगा हमारा particular integral. Okay, so this was all the theory in the chapter of differential equations. ये सारी theory मैंने आपको समझा दी है. And in the next lecture I shall be starting with the problems on differential equation, and we will solve very important problems from the previous years. So I hope you people are enjoying my lecture. So do give us your valuable feedback. हमें अपना important feedback देते रहिए. और जितने भी मैथ्स के चैप्टर हैं, मतलब जितने भी फर्स्ट लेक्चर्स होंगे इंट्रोडक्टरी होंगे जो कि थ्योरी होंगे वो 1 घंटे के अबाउट होंगे और बाकी वाले लेक्चर्स हमारे नॉर्मल चलेंगे. सो अपने फ्रेंड्स और कोलीग्स को भी हमारे चैनल के बारे में बताइए सो दैट एवरीबडी इज बेनिफिटेड ऑन अ लार्ज स्केल. एंड डू स्टे ट्यून्ड बिकॉज हमारे चैनल पे कई सारे अब इंपॉर्टेंट वीडियोस हम लोग लोड करेंगे रिगार्डिंग हाउ टू सॉल्व द प्रॉब्लम्स, हाउ टू अटेम्प्ट द टेस्ट सीरीज एंड ऑल दैट. सो थैंक यू सो मच फॉर टुडे.